Okay, two astronauts with masses m1 and m2 say goodbye and push each other off in the space. The initial velocity of the boat was 0, and after the push-off, the astronaut with mass m2 moves with velocity v2. How much energy was input in the push-off? Okay, so what we know for sure? We know for sure that we have two masses m1 and m2, and we have velocity v2. First of all, we need to find velocity v1. Why? Well, because. Okay, and we find that from the momentum conservation. What is the meaning of this? So, momentum conservation, prior to the push-off, momentum was 0, and after the push-off, momentum will be also 0. So that means m1 v1 minus m2 v2. Right? What did I do? What did I do now? Minus, strange, m1 v1 minus m2 v2. Why is this minus? Because if it's v positive in this direction, this will be a negative direction for v2. So from this equation here, we arrive to this one here. That means momentum for the one is equal to the momentum of another. And we have all these known quantities, and there is v1 that is unknown. And from here, v1 is simply this one. That is for the momentum. Now for the energy. The energy input in this case should be sum of final kinetic energies. So we have one kinetic energy and the other. And we have v2 for v2, and for v1 we will exchange, instead of this, this. And then we will get the kinetic energy of the system after the push-off. And that's all there is to it. You just fiddle this to the end, and you could do that on your own. Or for complete written answer, please follow the link in the description. If you want more of this, please subscribe and tell your friends. Now, just one thing to mention. In the reality, this is very rarely happen, because this is more like, in reality, this is more like inelastic collision. But I calculated here, because I thought that your teacher expected that, I calculate here as completely elastic collision, in a way. So that is that, nothing more. See you, bye.